Alright, thanks for watching, and today I would like to give you another example of a change of coordinates matrix with respect to the standard basis. And I have done another video on coordinates where I introduced this a little bit. Now today I want to do a slightly more abstract example. And in another video I will do the general case where you do a change of coordinates matrix from B to C. But still, it's very important. So, for example, again, just want to show you that even abstract stuff, you can do it similarly. Let's find the coordinates of P with respect to B, where P is the polynomial 3 plus t, and B is the basis 1 minus t and 1 plus t. And here it's a basis of the space of polynomials with degree less than or equal to 1. First of all, don't be scared of this thing here, like 3 plus t and 1 minus t, 1 plus t. Just think of this in terms of coefficients. So technically you have to do another change of coordinates from this space of polynomials to R2. But really, you can think of this as the vector 3, 1, and this as the vector 1 minus 1 and 1 plus 1. 1 and 1. And the first thing is to put those vectors together. Then you get a big matrix called PB. So it's like PB and J, which is 1 minus 1 and 1, 1. And careful, do not confuse PB with P. This is just a vector, this is a change of coordinates matrix, and this is what's called the change of coordinates matrix from B to the standard basis. And it's not clear why it's called the standard basis, but it'll be clearer once I talk from PB to C. So we have this, and what does PB do? It does something very interesting. I like to think of it as a barcode scanner. Namely, it takes coordinates as its input, so think of it as a barcode, and it spits out the original item. So literally like a scanner. What does a scanner do when you go to a grocery store? It reads the code 4786 and says, oh, it's an apple. And that's precisely what it does. So now what we have to do, it's simply, we get, using this formula, 1 minus 1, 1, 1. Again, the stuff we want to find, so PB, equals P, but P, remember, if you think of it in terms of coordinates, is just 3, 1. So to get PB, you just invert this matrix, or you row reduce, up to you. PB is 1, 1 minus 1, 1, inverse 3, 1. If you calculate the inverse, it's 1/2 1, 1 minus 1, 1 of 3, 1, and you get 1, 2. Okay, but careful. Oh no, not careful. This is the answer. So really, because the coordinates are numbers, so that works. And what is this really saying? It says that P, which is the polynomial 3 plus t, in terms of our basis 1 minus t and 1 plus t, is just equal to 1 times this vector plus 2 times this vector. So you have to go 1 step in this direction and 2 steps in this direction to get the vector 3t. And in fact, this is why we actually have this formula. Because in order to ask what are the coordinates of P with respect to B, you just want to ask yourselves how many steps in 1 minus 1 and how many steps in 1, 1 do you have to go to get the vector 3, 1? And A, B are precisely those coordinates of P with respect to B. So You see, even though this was an abstract example, hopefully that's not too bad. And next time I'll definitely do change of coordinates from B to C to see what's going on. Alright, I hope you enjoyed this video. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.